Hello, my name is Jonathan Michie. I'm an artist from the north of England. I started my artistic career studying glass and ceramics at the University of Sunderland, based at the National Glass Centre. After graduating, I got a job as a designer and a maker in the prop making industry, and I now currently work as a technical tutor for Ravensbourne University in London. In 2019, I was honoured to be awarded the prize as for the International Glass Artist of the Year by the Glass Art Society. As part of this prize, I was invited to deliver a lecture at the 2020 Glass Art Society conference, which was to take place in Sweden. However, due to the global pandemic of the coronavirus, this conference sadly couldn't take place, and instead it is taking place as a virtual conference. This is the presentation that I prepared for that conference, and I hope you all enjoy it.
Most of my work is based on the natural world. These are mainly life-size sculptures of animals made of shards of glass. And in the creation of these pieces, I use a range of digital processes, as well as more handcrafting techniques. However, I've experienced mixed feelings towards the use of digital technology in the craft world. In this presentation, I'm going to examine why this is and how the use of modern technology fits into the larger craft world. I'll begin by briefly examining the history of craft and compare how the standards of modern craftsmen compare to those of their predecessors. I will highlight various disciplines that could be considered craft art in the modern age, and then outline the numerous roles that contemporary craftsmen are assuming in order to succeed. Finally, I will conclude by considering whether the definition of craft needs re-evaluating. The question underpinning this presentation is whether the term craft is regarded as an absolute, or whether it constantly evolves to match the technology available while retaining the originality and uniqueness of the objects produced. Along the way, I will interpose images of my own work and talk about my experience incorporating these different pieces of technology into my practice. The arts and crafts movement versus the Industrial Revolution. Craft as an art form has long been associated with the ideals of the arts and crafts movement of the late 19th century. And this movement arose as a reaction to the increase in the mass production brought about by the Industrial Revolution. The arts and crafts movement demonized certain methods of manufacture, such as the use of machinery to aid production and the division of labor, and instead it advocated the use of traditional craft methods of construction. It perpetuated the belief that an individual craftsman or team of craftsmen should complete their work single-handedly without breaking down the manufacturing process into a series of steps, and in this way they thought that individuality would be returned to the production of everyday objects. The Industrial Revolution began in Britain from about 1750 and lasted until around 1850. The revolution was characterized by a transition to new manufacturing processes. This transition came about as the result of a series of technological breakthroughs, beginning with the cotton, textile and iron industries before quickly spreading to all other major industries through the course of the centuries. The key to these breakthroughs was the application of power to the manufacturing process. These new machines had a number of features that made them different to the technology of the past. Firstly, they were very expensive, which limited ownership to a few. Secondly, they required many workmen to operate them. And thirdly, they were dependent on a constant source of power. These differences gave rise to factories owned by wealthy capitalists. No longer was production carried out by individuals in their own homes or small workshops, as had previously been the case. Instead, it was carried out by collaborative effort involving many workmen and reliant upon power and machinery located in factories. This change allowed for the mass production of items produced to a standard design at low cost rather than the manufacture of expensive bespoke objects. The assumption underlying the arts and crafts movement was that this division of labour and mass production that were the hallmarks of the Industrial Revolution led to a decline of creativity in design. They believed that creativity was the product of an individual who was able to control the whole process of manufacture from the initial concept to the creation of the finished product, and hence the Industrial Revolution was seen as a backward step as it brought about a reliance on machinery for production and relegated manufacture to a series of workmen who had not been involved in the original design of the product. The members of the arts and crafts movement stated that craftsmen should not rely upon machinery and they should be solely responsible for their work from the initial concept to the completion of the final piece. However, even for Morris & Co., this model was a fantasy. Initially, they aimed to manufacture every item by hand using only a small team of craftsmen, but when demand was high, they discovered it was impossible to produce their wares quickly enough. Even with the use of machinery and the division of labour, they were forced to make their products very expensive. Nevertheless, this stereotype of a craftsman still exists today, and craft is widely associated with manufacturing techniques found before the Industrial Revolution. However, this was not what the term craft had originally meant before the arts and crafts movement. Prior to the Industrial Revolution, craft was simply used to describe the most efficient method of manufacture. And in fact, the techniques and tools that are today viewed as traditional craft processes were the industrial technologies of their time. Traditional versus technological. There appear to be two reasons why this anti-technological view has continued into the modern age. Firstly, there are those who agree with the complaints of the arts and crafts movement. They are tired of mass-produced objects and unimpressed by the lack of originality in their design. People long to see the evidence of the hand of the maker in the object because they value the skill that went into its manufacture. And secondly, there is a concern amongst craftsmen that certain craft techniques which require much time and skill to master will either degenerate or completely disappear. These skills will instead be replaced by a reliance upon advanced technology. With all that being said, there are a number of improvements that have come along with these advancements in technology. Firstly, computer-aided education. In the past, craft techniques were often the exclusive property of guilds, which restricted admission and required a long and expensive apprenticeship. However, that is no longer the case. The modern craftsman has the ability to experiment with a vast range of tools and materials with unprecedented ease thanks to the assistance of machines. In addition to this, when it comes to learning how to use a certain piece of technology, there is no better resource than the internet. YouTube is a seemingly endless source of information on how to use tools, software and materials. And when YouTube fails, there are forums and distance learning resources. And after all of this, there is always the possibility to email a specialist and ask for advice. Today's world is completely interconnected, thanks to the advancements in technology. It is possible for me to order materials from Africa, tools from Japan, and follow the techniques of a craftsman from Australia, all from the comfort of my own home. This new cross-fertilization of craft practices could lead to innovation and help to push craft forward into the future. However, thanks to this new culture of digital self-learning, the modern craftsman has the ability to flit between disciplines and learn basic skills in a very short amount of time. And there is a fear that this new mindset opposes specialism. If the modern craftsmen are not prepared to devote the required length of time to fully master a traditional craft, then these skills could diminish and the demand for them could wane and die out. Through the course of my life, I have learned a great deal from the internet. I constantly find myself being amazed by something someone somewhere has created, and this leaves me eager to find out how they accomplished it. And with enough research and trial and error and emailing, this is possible most of the time. I feel that this method of investigation has really helped my ability to learn. If I were to simply rely on a tutor or a colleague to tell me everything that I needed to know, it would be unrealistic, and it would also deprive me of learning the valuable skill of self-teaching. In my current job, it involves teaching university students how to design and build prototypes and final works of art. I teach both traditional modelling techniques as well as digital CAD/CAM processes. However, at the time of this presentation, we were all in lockdown brought about by the spread of the coronavirus. And in order to teach remotely, I'm producing videos teaching my students how skills which they can do in their own home. And without computer-aided education, this would not be possible. In addition to this, I'm also compiling a directory of websites and videos and forums that I find helpful. And I'm sharing this with the students in the hope that this will become an open document where students can add to it and change over time, so that we can all learn together in a truly open source manner. Secondly, computer-aided design. Using a computer to aid design is standard practice in most manufacturing industries today. However, it has yet to become fully integrated into the craft world. Computer-aided design came into being in the 1960s, and it was initially used by the automotive and aerospace industries. And similar to the emerging technology of the Industrial Revolution, the use of CAD software was at first limited to just the large corporations, because powerful computers were very expensive at that time. It was not until the 80s that it became available to the wider public, and it wasn't until the 90s that 3D modelling was really possible. Craft of the past had an inherent link to human anatomy, and this is because of the techniques that we use to create it. The curves of a hand-thrown pot are formed by the contours of the human hand, and its size is restricted to the limits of the human body. And there is a fear that this link between the human body and the craft item will be lost when a screen is interposed between the design and the finished item. However, I personally find this separation to be beneficial. An artist's ideas can be constrained by their own making ability. This can hinder their designs, and their imagination is not allowed to stray too far from their own comfort zone. But computers are not without their own their own intentions. The creators of these pieces of technology imbue the software with their own preferences and logic, and an artist must wrestle back control of a piece of art from a computer, lest it merely represent what the computer wants to create and not the ideas of the designer. This is a key consideration to take into account when using any tool. All tools influence our imagination. If you sketch with a pencil, you instinctively imagine all the possibilities achievable with a pencil. And an artist can free their mind from these limitations by incorporating a variety of methods of creation into their workflow. The work of art should determine the tool used, and not the other way around. When I first started studying, I had no experience of computer-aided design. Nevertheless, I had grown up under the influence of video games and the internet, and this upbringing had shaped my view on the world and inspired the art that I wanted to make. This was the first piece of art that I made using glass in my first year at university. I had all these big ideas. I wanted to blend a modern digital art style with traditional stained glass techniques. And traditional stained glass windows are comprised of shards of glass cut into basic shapes, and when these shapes are combined together, they reveal the complex image of the window. And Windows were created in this way for a number of reasons. Firstly, it was impossible to produce large sheets of glass until the 19th century. And secondly, the shapes of the glass needed to be simple due to the way in which the glass was cut. Glass has to be scored and then broken, which makes it difficult to cut overly complex shapes. Nevertheless, this fragmented geometric art style of these windows reminded me of the video games that I played as a child. These games were considered cutting edge and revolutionary at the time. However, they would now be considered outdated or retro. And one of the reasons for this is because of the number of polygons that were used to make up the characters and environments in the game. The number of polygons in a computer mesh determines, or is a determining factor of the speed at which the game can be rendered. And when a computer is less powerful, a model with low polygon count must be used to keep the game running at an acceptable frame rate. But computer engines have become so powerful over recent years that models with millions and millions of polygons are used today. However, to some people, this low poly art style is still visually appealing, like me. But I used the image of David Attenborough cradling the chimpanzee as a reference for the piece, because not only did I want the digital style of the piece to be a complete contradiction to the traditional stained glass pieces, I also wanted the subject matter to be a direct contradiction to traditional stained glass windows. Stained glass windows often depicted religious scenes from the Bible, and David Attenborough's nature documentaries have shown me amazing things and have helped to understand my view on the world and of science and of evolution. After finishing the David Attenborough piece, I thought it was a good start down this path that I wanted to go down, but there was more to do. And in the beginning of my second year at university, I applied for an exhibition which was to be held in a park in Gateshead, which is near to where I studied. And the theme for the exhibition was A Midwinter's Night's Tale, which is an amalgamation of two Shakespeare plays, A Winter's Tale and A Midsummer Night's Dream. Now, I had no knowledge of any Shakespeare plays, but I quickly researched the two plays, and I found that there was a stage direction in A Winter's Tale, exit pursued by a bear, and this stage direction had become quite famous. It signifies the off-screen death or off-stage death of Antigonus, and it implied that this character had been savagely killed and eaten off-stage by a bear. So I decided I would design a glass bear to stand at the exit of the park and scare away the visitors. Now, I was eager to improve upon the style of the David Attenborough piece, but by creating a two-dimensional image of this low poly aesthetic, I had reduced this style to a form of abstraction, almost like an imitation of cubism. But this was not my intention. Low poly meshes in early video games were not design choices, they were a necessity. And when playing a video game, I would suspend my disbelief and allow myself to become immersed in this alternate reality. These jagged, low poly objects were perfectly normal to me, and I viewed this style as the style of the alternate world and not a limitation of the hardware. I wanted to bring this style into the real world as if a game model had escaped from the screen and entered into our world. Much to my surprise, the proposal was selected, and I was now faced with the daunting task of figuring out how I would construct a life-size bear out of glass. Computer-aided manufacture. Now, a number of craft artists have begun to incorporate modern technology into the creation of their work. This is due to the accessibility of emerging technology and the reduction of its price in comparison to the machinery of the Industrial Revolution. And the modern digitally aware craftsman has the ability to combine traditional techniques such as carving and casting and smithing with digitally aided technology like CNC milling and sintering and robotics. And they are free to take inspiration from a wide array of fields such as engineering and computer science and architecture, and blend them all together with their traditional craft knowledge in order to make something truly fresh and modern. However, there are those, such as Howard Rosati, the author of A Theory of Craft, who don't see this as a wholly good thing. He believes that the goal of machine production, after all, is the elimination of the skilled workmanly hand, and thus the elimination of work itself. By saying this, he is implying that the sole purpose for the advancement of technology is simply to make a goal which was already achievable through traditional methods easier to achieve. In my opinion, this is entirely dependent upon the person utilising the technology. Certainly there are those whose main ambition it is to eliminate the need for hard work and reduce the cost of labour. However, there are also those who are eager to find out what is possible using these new tools that was previously impossible. Geoffrey Mann, for instance, attempts to capture intangible, invisible phenomena in his work through the use of digital techniques. In his series Crossfire, he was able to visually depict sound waves, and in order to accomplish this, he captured the sound file of the dinner time argument scene from the film American Beauty, and he used sound visualizing technology in order to view the effect of the sound waves on a set of computer model tableware. These digital models were then 3D printed, and molds of the molds of the prototype were made, and then the final pieces were cast. And this project is a great example of what can be achieved when traditional craft art techniques and avant-garde digital modeling techniques are combined together to create something previously unimaginable. Craftsmen have been using technology for hundreds of years. What makes the technology of today any different from the machines used by our predecessors? Is it their power or their efficiency? These were all goals that creators in the past longed for. Another criticism surrounding the use of machinery in fabrication is that it is believed to require less skill than traditional craft processes. Digital 3D modeling is a skill and can take a long time to master. Believe me, this is a large part of my job, is to teach people how to model in 3 dimensions. In addition to this, preparing a file to be realized in physical form, whether through the use of a 3D printer or a CNC mill or a router or any other piece of computer-aided machinery, carries with it a number of potential issues that an artist must become familiar with. Care must be taken when designing an object, programming the machine, and choosing the material. A craftsman needs to have a good working knowledge of the material they are working with, the mechanical process they are using, and the potential risks associated with it in order to have a successful result. The appeal of a new piece of technology fades over time. Whilst people may be initially awestruck by a 3D printed object, this wonder dissipates as the technology becomes more commonly used. People become accustomed to the limitations of the technology and they expect more. It is up to the artist to incorporate these new tools into their toolkit where appropriate. Okay. Back to the bear story. When considering how I would go about creating the bear for the park, my first thought was to utilize computer-aided manufacture and to have all the sections of the bear CNC milled out of foam. I thought I could then build a structure around these foam sections, and the final piece should resemble my computer model. Unfortunately, the Fab Lab near to my university was closed at this time in order to remove asbestos from the ceiling. So I visited Durham University, which is the town that I lived in, to see if I could use their machine. And they told me that their machine was currently out of action, and as I was not a Durham student, they would have to prioritise their students over me, so they wouldn't be able to do my work. However, they did put me in touch with a company that had installed the CNC machine at their university, and so I set up a meeting and I drove out to this company in an industrial estate, and I spoke to their manager, but he was unsure if they'd be able to do their job. But he said they'd give it a try. So I left my files with them and then a few sheets of insulation foam, and went on my way. After a few days, I was contacted by the manager, and he sent me a picture of the progress that they'd made. They had cut 5 sections of the foam. This had taken over 2 hours to cut, and it was going to cost me £170. Now I needed roughly 100 pieces to make the bear. So I realised really quickly that this would not be a viable method of construction. So in the depths of my despair, I was sitting at home and I had a eureka moment. I printed out the triangles that made up the computer model of my bear, and I cut them out of paper, and then I glued them to some card and I cut that out. And then I started attaching all of these triangles together, edge to edge. And this gave me the outer shell of my bear. And then I stuffed the inside with soft objects to give it the shape, and then this gave me a form that I could start building around. I started cutting wooden lengths of doweling to fit along the edges of the triangle, and I used wood glue to fix them all together. I covered the joints in masking tape to hold them in place and stop the glue from seeping away. And I continued this process day and night until the wooden structure was completed. It was also December in the north of England, and it was freezing cold, and so the glue wasn't drying. So I got these portable radiators, and I positioned them next to each piece I was working on to dry it out, and it somehow seemed to work. Now, I was very fortunate in that the National Glass Centre, which is where I was studying in Sunderland, had a water jet. And a water jet is a machine that cuts objects by firing a high-powered jet of water through them. This jet of water is mixed with an abrasive grit made of garnet, and this can cut through. You can cut through stone, it can cut through incredibly tough materials, but it can also cut through glass without cracking it, which was great for me. So I was able to get all of my glass cut on a water jet, and this was the first computer-aided manufacturing process that I had used, and this was a real lifesaver for me. Without it, I would never have been able to cut all the glass in time, and I would have had a lot of wasted material. Through working in this method, I was also able to cut little holes in the corners of the glass, and I could attach the glass to my structure using cable ties by fitting them through the hole and wrapping it around the wooden doweling. This whole building process took me a month to complete, of working day and night, but it was a real turning point for me in my artistic career. However, after I completed the bear, I was still unsatisfied. There were a number of aspects that I thought I could improve on. Firstly, I thought that the bear, in the design, it sort of looked very static and lacked a sense of excitement. It didn't look like it was about to pounce on the visitors and eat them, which is what I'd wanted to accomplish with Exit Pursued by a Bear. My second criticism was in the method of construction, which I felt was rudimentary, and it distracted from the overall form of the piece. I was aiming to make a sculpture in which the glass would take centre stage. So in order to accomplish this, I began designing small joints that could hold the structure together as well as fix the glass in place. I wanted these joints to be elegant and to not distract from the overall form. And I realised as I was designing these more and more complicated joints that the only way I could go about manufacturing these would be through 3D printing. It would be incredibly difficult to make all of these parts by hand, and they would also lack the accuracy that I needed. Without 3D printing, I would have been forced to alter my design and use standard shop-bought parts, or fall back on the methods I'd used for the bear. Anyway, so I calculated there would be just enough time to print all of the joints before the deadline, provided that not too many of the 3D prints failed. And then once I'd printed all of the joints for an individual part of the stag, I would begin cutting the steel rods to length. Now, a real advantage of designing digitally allowed me to use my CAD model as a reference. So I could measure individual lengths on the model, and then I would cut a piece of steel to the correct length, and then, hey presto, they would all fit together. They would snap into their joints, and it was just like a game. It would fit together perfectly. I completed the head and the antlers first, followed by the legs and the body. But when I attached the head and the antlers to the body and the neck for the first time, one thing I hadn't taken into account was that the weight of the head and the antlers, especially with glass on, would start pulling the joints apart from the neck and the body. So in order to solve this issue, I attached a length of wire that ran from the stag's head back to his rear end, and it spread the strain more evenly and alleviated the pressure on the neck. In addition to this, I had not contemplated the lack of friction between the plastic hooves and the wooden floor of the gallery which it was displayed in. Now, when I tested the assembly of the structure before the installation, I had done so on carpet, and the piece had stood up without support. In contrast, when I erected it in the gallery, the legs began to slide forwards and on the smooth wooden floor. So, in order to stop this happening, I fixed some rubber to the soles of the hooves, and this created enough grip, and the piece didn't slide forwards, and it was all okay. Algorithm-aided design. In the wonderful book, the Nature and Art of Workmanship by David Pye, he comments that machine production can do nearly everything well except produce diversity. To him, this was the major flaw with machine-produced goods. If infinite copies of an object could be produced, how could special value be accredited to an individual piece? He observed that in every natural organism we see a dichotomy between the idiosyncrasy and conformity to the pattern of the species. No two leaves of the same tree are precisely alike. Each is individual, yet every one conforms to recognizable pattern characteristics of the species. This harkens back to the criticisms of the arts and crafts movement. Algorithmic design allows artists to create a process rather than simply a single object. The completion of this process results in the finished design. However, the steps involved in an algorithmic design remain modifiable. This means that the designer can alter the algorithm at any time to yield a different result. This process affords the designer the ability to make changes to their design without having to completely remodel it every time. And it also enables infinite variations of the same base design so that each individual piece created can be unique. Here I am using the algorithmic design software Grasshopper, which is inbuilt in Rhino, whilst working on a design that I'm working on at the moment. The Design Studio nervous system use algorithmic software in order to create their works of art. Their algorithms attempt to mimic the structural growth patterns seen in nature, and in addition to each piece of art being unique, all of their pieces are printed on demand, which means that there is no need to stockpile artwork or to waste time manufacturing unneeded stock. Through the use of algorithms, it is also possible to create models which are able to recognize external factors and adapt accordingly. This gives designers the ability to deal with real-world problems in a way that traditional methods have always struggled with. The structural integrity of a work of art or the effect of environmental stresses such as wind or gravity can only be solved in the past by prior experience or advanced engineering calculations. But now these factors can be calculated accurately during the design process, and the outcome can be tailored to overcome these factors. This is something if I had more experience in algorithmic design, I could have conquered the problems of the stag during the design process and not had the issues I did. Now, in order to design all of the joints for the stag, I taught myself how to use algorithmic design software, in particular Grasshopper, which runs alongside Rhino. This was a great challenge for me, and it required me to change my entire thought process when it came to design. I now view objects as a series of steps or a recipe rather than some magical finished piece. Designing all of the joints of the stag individually would have been an impossible task. Each joint is unique and they each have to be accurate, otherwise this would lead to problems of pieces of glass not fitting together and the whole thing not standing up. Also, if I had not designed algorithmically, I would have been forced to remodel every joint every time that I altered the design. So this really showed to me the advantages of working in this way and using algorithms effectively. In addition to this, by creating the algorithm for the joints of the stag, I could simply input a different model to generate the same method of construction for a different piece. Whilst I was constructing the stag, I was able to enter another competition. I designed a lynx to sit atop a wall in a sheep farm in Northumberland, and at the time there were plans to reintroduce the lynx to the north of England, and there was opposition from the farmers who thought that the lynx would hunt their animals. And I thought this would be a controversial piece of artwork to make and sit atop a wall in a sheep farm. The final aspect of the advantages of using technology in the craft world I'd like to talk about is self-promotion. The impact of computer technology on craft has not been confined to production and design. The internet and social media have revolutionized the way in which modern craftsmen can interact with customers and sell their wares. Today's craftsmen have the ability to promote themselves through the use of social media platforms such as Facebook and YouTube and Instagram like never before. This is a powerful tool for the modern craftsman. In the past, a craftsman would have been forced to toil away in a back room hidden from public view with no way to entice new custom except word of mouth or chance encounter on a market stall. Now modern craftsmen have the ability to communicate directly to potential customers across the globe with ease, thanks to the internet and social media. It is imperative for modern craftsmen to increase their internet presence if they hope to survive. However, standing out from this crowded world of social media is difficult and requires substantial time in the form of performance and promotion on behalf of the craftsman. In addition, as this method of self-promotion becomes more commonplace, consumers are beginning to take for granted the ever-increasing effort that craftsmen are putting into representing themselves online. Craftsmen have begun to realize that it simply isn't practical or efficient to spend a large amount of time creating a piece of artwork when customers can find a much cheaper mass-produced alternative. Ironically, it is the technology that the craftsmen of the past most feared which has the ability to set today's craftsmen free. Some of the modern craftsmen who have infiltrated the world of mass production are utilising their machinery in order to make a living as a craft artist a realistic ambition. With the use of computer-aided manufacturing processes like 3D printing, laser cutting and CNC milling, the modern craftsman has the ability to control the production of their work at minimal extra effort. Coupled with the way in which the internet has revolutionized marketing and distribution, craftsmen have the ability to control every step of the process. I believe that the craft artists of today owe a great deal to the artists who came before them. However, we should not merely be content in replicating their work. Everything that we know about working with our chosen materials has come from their successes and failures, and modern craftsmen should be inspired by the art their predecessors created and should learn from their methods of manufacture. Although they should not be afraid to combine and alter these processes in order to make something original. We are a product of the time we live in, and we should focus on making work that is the best example of what is possible in today's world. That is to say, we should allow ourselves to be influenced by all of the artwork that has come before us, and we should take advantage of all of the technology that now exists. While the new aesthetic that has emerged alongside the advancements in modern technology is a far cry from the style of artwork created by William Morris and his friends, there are similarities to the core ideals of these two movements. The arts and crafts movement sought to create total works of art, where a craftsman would serve as both designer and manufacturer. Modern fabrication technology makes this a possibility in a way that the arts and crafts movement could not. Thanks to the advancements in technology, today's craftsmen have the ability to design, manufacture, advertise and batch produce their own work without any industrial assistance. There is a continuous interaction between advances in technology and those that use it. The use of computing technology today is transforming many different aspects of the creative and productive process. What is required is a definition of craft that is not static but dynamic. Craft is workmanship of the highest standards executed by a person who is the master of the technology available to them. Such a definition would apply equally to a member of the medieval guild as a digital technologist today. It is quality of design and finish that defines craft, not the tools or the materials used. Thank you.
I hope you all enjoyed this presentation. It was slightly different than how I'd anticipated delivering it in person in Sweden, but these are the times that we live in. I hope it went down well, but I would love to hear your comments, whether positive or negative, and yeah, hopefully I'll be able to meet you all in person soon. Bye.